integration by parts. We've been learning this in my Calc 2 class recently, and I've learned of something called cyclic integrals, which are special kinds of integrals that I want to show you guys how to solve. And I already have it started out here with our U substitution and our ultraviolet magic voodoo something. I don't know. I just learned this. So I'm hoping I can help you guys understand it too. So now when we go back we're gonna have to take this integral multiple times, but now we get 1/2 e squared theta times our u, which is sine of 3 theta, minus our integral of, and we do the v du together, 1/2 e to the second theta, 3 cosine 3 theta d theta. And we can combine these here and say that this is 3/2. And now when we do u substitution again, or I guess it's technically called integration by parts, we have our u is going to be our cosine of 3 theta, because it follows our acronym here, Lite, logs, inverse trig, algebra, regular trig, exponents. And so trig comes before exponents, so we'll do cosine 3 theta as our u, du equals, we do a quick chain rule, it'll be -3 sine, the inside stays the same, 3 theta, keep the d theta, that's important. And then for our dv will be the 3/2 e to the second theta, and we take the integral of that. Our v will equal, let's see, 2 theta. It should be 3/4 e to the second theta. Nice. Okay, I'll switch to pink now to show you guys. So remember this part, we'll come back to it up top here, but we'll come back down here, and with our uv, we'll do 3/4 e to the second theta times cosine 3 theta, minus our integral of 3/4 e the second theta times -3 sine 3 theta d theta at the end. And don't forget this part up here, but we'll come back to it. So now we can do some simplifying. We'll just simplify this side right over here and distribute the -3. That should get us a -9/4, I believe. And we can actually take this and put it on the front side of the integral. And so you'll see now we get just integral e squared theta times sine of 3 theta d theta. Now watch this. This is fire. So doesn't this look kind of familiar to what we had when we started this? The e squared sine 3 theta d theta. And so now that we have this as part of our integral, we're going to take this. Actually, we're going to include the integral symbol in it. The only part we're going to exclude is this -9/4. But we're gonna give that a name. We're gonna call it I. It's a variable now. And this is why I love this, because physics is a ton of fun and messing around with variables. Now we have two i's, and when we have two variables, we can cancel stuff out. So now we're gonna take our three parts that we've solved for and put it all together. So I'll be back in a second. Okay, so we get our minus 9 over 4i, obviously from this bottom part here, and this middle term here, we got it from this part right up here, and our very first term was from that first time when we took that first integral. So now we have two i's in our equation, which is super nice because we just add over, we can add a 9/4 I to both sides and get 13 over 4i equals all of this. And now, bada bing, bada boom, we move this down. Our 13, we want to get just one I, we erase this. We can multiply, here, let's write it like this. I equals 4 over 13 times all of this we have right here plus c. And here we have our integral, or the integral of e 2 theta sine 3 theta d theta. It takes a while, but I promise if you study and give it a few goes that this is pretty awesome and will actually start to make some sense. So good luck on your homework, and I wish you very much luck figuring out integration by parts.